Hello everyone, my name is Stefanie Bruinsma. It's my pleasure to welcome our audience and speakers today for today's Alumni Speaker Series in Autonomous Vehicles, the Hope and Hype of Self-Driving Cars. Before we begin, a few housekeeping items. Today's session is being recorded and will be available on YouTube for viewing. A link to the recording will be sent out after this session in the next few coming days. And please submit your questions in the Q&A section and we will answer as many of them as possible as this event progresses. First, I would like to take a moment to publicly acknowledge the traditional territory upon which we live and work, as it is an important step towards reconciliation. The University of Waterloo acknowledges that much of our work takes place on the traditional territory of the Anishinaabe and Haudenosaunee peoples. Our main campus is situated on the Haldeman Tract, the land granted to the Six Nations that includes 6 miles on each side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, community building, and is centralized within the Office of Indigenous Relations. So again, my name is Stefanie Bruinsma, and before I introduce our esteemed experts today, I'll tell you a bit more about myself. I am the Manager of Industry Engagement in the Engineering Research Office here at the University of Waterloo. I have a lengthy and unique history with the automotive industry. I became licensed as an automotive technician in 2007, and I built upon this with a bachelor's degree in mechanical engineering in 2015. I also have a love for lifelong learning. This year, I completed my Master's of Business, Entrepreneurship, and Technology through the Conrad School of Entrepreneurship in the Faculty of Engineering. And in addition, I am the founder of AutoKate, a service currently in active beta pilot that helps car owners ensure they are never oversold on car repairs. I am honored and excited to be the moderator for today's Alumni Speaker Series session, hosting panelists with a diverse background, but each with a unique mission of addressing advancements in transportations and how AVs will impact the way we travel every day. Autonomous vehicles, or more commonly referred to as AVs, are now enabling opportunities in the transportation sector, specifically challenging the ways in which we think about how we move around. From dreams of being released from the morning commute to accessible transportation for everyone, AVs are disrupting the automotive industry. Researchers at the University of Waterloo, as well as industry, create a unique Canadian ecosystem where interdisciplinary research is being conducted on dynamic vehicle routing, future transportation systems, planning under uncertainty, sustainability and energy, infrastructure systems, vehicle communications, and data processing. Just quite a list. Our panelists today will reveal the impact AVs will have on the ways in which we move, their barriers to mass adoption, and further implication they may have on transportation and adjacent ecosystems. We have 3 panel speakers for today's session. They are Lisa Aultman-Hall, Stephen Smith, and Amar Varma. Lisa Aultman-Hall is a professor and chair of systems design engineering at the University of Waterloo. Dr. Aultman-Hall focuses on transportation systems, especially methods to collect unique databases for modeling and analysis of long distance travel, transportation sector emissions, network resiliency, streetscape design, and non-motorized transportation. Until recently, she served several leadership roles at the Interdisciplinary University of Vermont Transportation Research Center. Dr. Aultman-Hall is active in several roles with the Transportation Research Board of the National Academics. Dr. Aultman brings modeling of world social behavior to the modeling of charging demand for electric vehicles with the Joint Clean Climate Transport Research Partnership, led by the University of Quebec. Her expertise in automated vehicles focuses on how they will be used for passenger travel, including long-distance trips and elements of equitable access. Stephen Smith received his BASc degree from Queen's University and his MASc degree from the University of Toronto, and his PhD from the University of California. He is currently an associate professor at the Department of Electrical and Computer Engineering here at the University of Waterloo, where he holds a Canada Research Chair in Autonomous Systems. He is also a faculty affiliate with the Vector Institute in Toronto, Canada. From 2009 to 2011, he was a postdoctoral associate in the Computer Science and Artificial Intelligence Laboratory at the Massachusetts Institute for Technology. Professor Smith has received several awards, including 2 Outstanding Performance Awards from the University of Waterloo. He is a licensed professional engineer and with Professional Engineers Ontario and an active member of IEEE, serving in several capacities. His main research interests lie in control and optimization for autonomous systems, with a particular emphasis on robotic motion planning and coordination. Amar Varma is University of Waterloo educated, Silicon Valley trained engineer and entrepreneur based in Toronto. His career spans decades of intense and diverse industry experiences ranging from semiconductors, communication systems, cloud infrastructure, enterprise software, AI, security, crypto, and apps. Amar is a second generation University of Waterloo alumni, as he is followed by his father, who earned 2 engineering degrees from Waterloo. After graduating from Waterloo, Amar moved to Silicon Valley to work in the semiconductor industry, where he was part of the team that brought USB 1.0 and voice over packet technologies to the market. From these experiences, he got the ultimate training for a lifelong ambition of making the world a better place through innovation. His next chapter included a stint working at a VC firm where he got to see the table from the other side, completely providing him with insights on both the company building and financing processes. In 2008, Amar founded Extreme Labs, an apps development company. Extreme Labs was on the cutting edge of developing mobile app development as the App Store was launched. The company was purchased in 2013 by Pivotal, a software cloud platform. In 2016, Amar founded Autonomic AI, a vehicle connectivity platform with a vision to be integral and part of autonomous vehicle solution. In 2017, Ford Motor Company announced that 100% of its vehicles would be connected to the internet and subsequently acquired Autonomic. Today, there are millions of vehicles connected to the platform, processing billions of messages per day. All right, let's get started. We are going to start our conversation by laying the groundwork for understanding AVs, their classification, their current state of communication, and how they are affecting transportation industry. Stephen, my first question is to you. As our technology progress continues, there have been developments of different levels of autonomous vehicles. Could you outline the categories of AVs and their differences? And could you also identify what level we're going to talk about today?
Sure, yeah. So I guess there's basically 6 kind of established levels of autonomy. It goes from level 0 all the way up to level 5 autonomy. At level 0 autonomy, there's nothing. It's just driving a vehicle as a human. At level 5, it's what you would expect, like the full autonomy. You know, you can read the newspaper or go to sleep in the car and it does everything for you. And then level 1 through 4 is kind of everything in between. So at level 1, we already have this in many, vehicles, personal vehicles that you would purchase, which is just the vehicle can control some aspects of the driving. It could either accelerate or brake, maybe adaptive cruise control, or it could even do some type of steering. At level 2, you can do both of those things simultaneously. So this is like, adaptive cruise control with lane centering, this kind of thing, right? You can drive on the road. You still have to pay attention as the driver. You're ultimately responsible for the vehicle, but you're doing a lot less of the kind of particulars. And the key defining aspect of level 2 is that you have to be available to take over at any moment. And so there's really no commercial vehicles available that are above level 2. Like even the Tesla autopilot technically is a level 2 system because you're on the hook as the driver. At level 3, it's kind of, you start to, instead of always being on the hook, it's like the vehicle can request for you to come back and take over control of the vehicle. This is kind of a tricky thing because in driving, it's fast paced. And so there has to be enough warning to be able to safely have the human take back over on the vehicle. Level 4 is sort of full autonomous driving, but only in certain scenarios. And so we think of things like, highway driving might be completely autonomous, but then when you get back into the city, a human might have to take over. And then, like I said, level 5 is full out autonomy. In terms of what we'll be talking about today, I don't entirely know. I think what most people envision with autonomy are level 4 and 5, right? Like it's just driving for you. That's probably where we'll focus, but there might be some discussion on these lower levels of autonomy as well.
Excellent, thank you. Amar, over to you. What is the current state of communication in the AV ecosystem? What role does Autonomic have in the development of these communication technologies?
Well, thanks, and welcome everyone for spending your lunch hour with us. It's very exciting. For me, I love the description that was just provided in the layers 0 through 5 of autonomy. I think that's a great framework that not only the research has shown, industry is using as well. What I think is exciting for Autonomic is we now have the ability for a vehicle to communicate status as data, which was otherwise processed by humans in a vehicle. So when I talk about that, it means basics like speed, direction, and then it can get very granular in detail behind the vehicle's firewall into, oil, not only oil levels, but air quality levels and all sorts of nice information that you can get from there. So Autonomic basically has a platform our platform does all of that aggregation and then silos all the information into various categories so that we can then broadcast and use the information as best required. So that's the basics of the platform. From there, you can do lots of sophisticated things. So in the ecosystem now, there's tweaks to driving that you can make. There's group sharing that you can offer. And then now that you start talking about autonomous vehicles, there's ways in which you can give instruction or provide direction to a person or a machine on where the vehicle should go, when, and at what speed, and all sorts of fun pieces of information. I would say for the industry, as much as we think we've come a long way and we've spent billions and billions and billions of dollars into production, we're early. Tesla is by far the leader in this half of the world, and I think for good reason. They've designed a vehicle to be a computer from ground up, and the rest of the industry is trying to play catch up and do that kind of thing. So I think for industry, if your vehicle that you have today is not connected, and I'll use connected in air quotes, you're in the dawn of a cell phone to smartphone era, to kind of give you context of history. So I'll pause there and we can dig deeper.
Oh, that was great. Thank you. Lisa, currently, how are AVs changing transportation?
So I guess I agree with Amar that, this is going to be a long process and it's going to be a while before we're being driven around in sort of level 5 autonomous vehicles. But I would encourage people to think about autonomous versus automated. Autonomous is kind of like they're out there on their own. They have everything they need to drive all inside themselves, and they don't have this communication that Amar is talking about with the rest of the vehicles or the infrastructure and the system. So I think I'm thinking about both automated and autonomous vehicles, but mostly automated. And I think the reality is that we're already seeing contributions to safety and emissions in the transportation sector because of AVs. We all know about the safety things, even anti-lock braking, right, which has been around for decades, is a system that has improved safety, and we like the little lights on our mirrors, and our parents and older drivers like them too, to help their blind spots. And so we're already seeing the improvements in safety, the backup cameras. And I think that we're on the cusp of really seeing improvements in emissions, the vehicle knowing where it is and how it's operating in terms of the second-by-second operating mode, and how much emissions it's producing out its tailpipe. It would be helpful, right, for a car to know that a big hill was coming up. And we're there. And we know we're already there with the cars turning off at the intersections, right, to save emissions, to prevent idling. And then I think the next change we're seeing in transportation is that it is motivating everyone to talk about things that we should have been talking about for a long time. But automated vehicles are a really exciting thing. And so you can talk about them at a dinner party. It means we can talk about electrifying the passenger transportation system as part of that. We can talk about ride sharing. We can talk about vehicle sharing. We can talk about land use changes and equity. Who's going to get this new technology? How are older drivers going to be helped? What are we going to do when we don't need parking lots anymore? How will we redesign our land use systems? So I think safety, emissions, and then actually motivating large numbers of people to talk about what do we want from our future transportation system. I think those are all three very good things that AVs are motivating in the transportation system today.
Oh, that's excellent. Got some great questions coming in that I will answer in the right section. But thank you everyone for your participation. This is great. So for our next topic, it's roadblocks, and that's why these questions are a perfect fit for this section. So it's the problems yet to be solved, transportation implications, issues of how to power AI and AVs. So we're going to shift and talk about how AVs will affect our life. Will we own our own cars? Will human behavior and our environment create opportunities or roadblocks? And what will fuel their mass adoption? Lisa, first question is to you. What are the wicked problems of self-driving cars? What are the implications of them in a broader sense?
Yeah, I think the top wicked problem we now have quite a bit of research backing up, and that is that when a household has an AV, it's going to turn into more driving, more passenger kilometers of travel, or vehicle kilometers of travel, as we call it. And so those more driving turns into more emissions, and it turns into more congestion. So the very problems we're trying to solve are actually going to increase when we have these AVs being used in the community. And that creates policy questions around how do we ensure that they're used the way we want. And you might be saying, what? Why do people drive more? What's that about? Well, the relocating of those cars, to maybe remote parking, or to go pick somebody else up at their origin after they drop us at our destination, or sending the car to pick up the kids on its own, or sending the car to pick up the pizza on its own. That's more miles of driving. It also means you're going to be able to choose different destinations. I don't need to walk to the restaurant down the street. My guests can come over, the wine and cheese, we take it out in the car, and we choose a restaurant that's in downtown Toronto. We just sit in the car and enjoy the cheese until we get to the restaurant. We've chosen to travel further because of the automated cars. And then ultimately this plays out over time, where what we've seen in COVID, where people decide they want to live in smaller cities or rural areas. We were talking about that in transportation research communities before COVID, because what we were seeing was that with automated vehicles and the ability to commute a longer distance and to work on the laptop during that commute, that we would all relocate our homes and we would travel further. So the wicked problem is quite frankly just that there's going to be more vehicle travel.
That is amazing and kind of contrary to what you kind of think of when autonomous vehicles. So thank you for that. Stephen, in terms of economics, will self-driving cars be a shared service instead of a personal purchase?
Yeah, it's a great question. I mean, I think in the near future, to me, that seems like for these higher level of autonomy, at least like level 4, level 5 autonomy, this will be the route, just because the sensors, the computation, it's all very expensive. And so, to make a car kind of economically viable, it needs to be replacing like a human operator or something like that, right? If instead I'm just sitting and reading the newspaper and the car is driving for me, it's good if I have if I'm wealthy enough that I can afford this, but it's not really a mass market kind of thing. And so I think instead, seeing vehicles that are like, this is why Uber for some time had such a large interest in it, is they see the advantage of, well, we could have a car running 24/7, right? That has no operator in it and does pickup and delivery for people. And this is what Waymo is already kind of doing in some US cities and looking to do more. So I think in the near future, this is one of the main areas where you'll see autonomous vehicles, or what I think of fully autonomous vehicles or almost fully autonomous vehicles taking place. I saw a comment actually in the chat, and I think it's exactly right. Another one that people are really targeting is autonomous trucking, right? Because again, it's like a slightly more structured environment. It's highway driving primarily. Maybe you can even only do routes that are like directly off the highway, right? You take an off ramp and you go to a warehouse essentially. And so these are other areas where they're like, you can run these vehicles more than you would be able to with a single operator. You can potentially replace an operator, which is very good in all the labor shortages and things that we've been hearing about. So I think in the near future, that's true. As like sensor prices come down and we find like better solutions and, mass market or, mass production and scalability and everything kind of takes place. And then we'll see this trickle down to the consumer market more and more, starting with the luxury consumer market. And then eventually, I think it'll be available on the, mid-sized vehicles or whatever, right, that we all drive.
Oh, awesome. Thank you. I'm going to ask one more question to Amar before I go into some of these questions that are popping up, and they're great. Keep them coming. We love hearing from the audience. So Amar, will self-driving cars become, pardon me. What technology will be needed for coordinating of shared service?
This is a loaded question. So one would argue it's already there. We have shared services today that can be something like community share, that can be rental cars, that can be ride sharing, ride hailing. At Ford, we're a global leader in trucks and things people use to go do work, so to speak, right? There's a good chunk of those are fleets, whether they're shared between a few people, a few hundred people or a few thousand people, right? They're ultimately a shared service. So I'd argue that the clipboard spreadsheet technology already exists in a lot of these places. The software already exists at mass scale around the world to offer these services. It's really a resource sharing, a resource allocation issue on, are we as a society trying to share them all? Are we as a specific geographic community trying to share them? So it kind of has a more, a human aspect to it that we probably need to understand better. But I would argue it's not a technology problem today. That's my sense.
I love that the terms in sharing models and in making it more human, less technology. That was great. So let's go to our first question. Thoughts on different approaches to solving autonomy. So LiDAR versus pre-mapping versus vision only. And I'm going to open it up to anyone who wants to respond.
I'll jump in here because this is been a debate that I've seen being in a semiconductor person my entire career. Why couldn't the LiDAR be a solid state solution, right? I think there are different schools of thought. There are some folks who think you don't need LiDAR, you can do pictures. Others feel strongly about LiDAR. Some feel strongly about both. I think when you see these solutions come to market, you will have a hybrid of outcomes based on use case, based on sophistication required. I'm hoping we see all of them and a winner emerges. I think it's probably too early to tell. What we do see working today, though, is LiDAR. We do see that working. We do see pre-mapping up there as well. Like the cruise on the highways now works that way, and we see pictures only from some commercial vehicles. So it's all three are out there. I don't think I have a crystal ball as to say what will win. I can dive deep into research and bore everybody for the next 30 minutes, but I'll save it for a follow-on question.
Great, thank you. Another question. Well, sorry, Lisa, did you have a comment? Yeah.
I was just going to add that one of the things I hope gets considered in which technology wins is ensuring that it works everywhere. So we do have to think about rural areas and non-city areas and northern communities potentially. In Canada, and I worry that if we just let the technology that works in the urban areas win, that we might create inequitable access, and maybe we counter that with other access measures. But I think there is an interaction there between the technological feasibility and providing equitable access to it all.
Lisa, thank you so much for that. I think as, certainly alumni, many of us are engineers here, we can get so excited about the technology that we just dive in and don't really take a step back to think about those implications. Thank you for that. So next question, will level 5 autonomy ever be able to efficiently deal with pedestrians who by their nature must be considered as unpredictable? And can pedestrians and AVs coexist in urban environments? Thanks, Stephen, you're
Sure. Yeah. I mean, it's a good question. It's definitely one of the biggest challenges, I think, in developing reliable autonomous systems. I mean, long term, I think yes, because we, in some sense, are the current computer that's on board a vehicle, right? And not, we're the perception system, and we do it. Maybe some people do it better than others, but I don't see any fundamental reason why a robot or autonomous vehicle cannot navigate among humans. I mean, I think one of the big things that happens right now is you have this very awkward trade-off between safety and kind of like making progress, being efficient, right? If you take like always worst case assumptions on pedestrians, then anytime there's a sidewalk close to a roadway, the car has to stop if there's a pedestrian there, right? Like just in the off chance they bolt into the road. And we as drivers don't do this, right? We watch for little indicators and whatever. And also the truth is drivers are wrong sometimes, and people generally tolerate much lower levels of risk in autonomous vehicles. But so I do think it's something that will be sorted out. I don't think there's like a fundamental reason why this isn't possible. It's just, and it's, I think one of the biggest things that people are currently researching is basically driving in urban environments and how to do this like efficiently and safely.
Great, thank you. These I can't keep up with these questions. This
Yeah.
Audience is really, really engaged and loving this topic. So thank you so much for them. Let's get to another one and keep this debate going. Okay, so once we get fully autonomous vehicles, how will we deal with vehicles needing to adapt to changing traffic regulations and laws as they cross jurisdictions? For example, the Ontario law requiring cars to move over for parked emergency vehicles. Who would like to jump in on that one?
I can mention very briefly that someone else can talk after, but this is another like great question. I think there are, again, people thinking about this, and there's this framework I've seen proposed called responsibility sensitive safety. That's kind of this idea that, like, you know, the safety that you're responsible for depends on the regulations in which you're operating. Like, for example, they also can have to do with like insurance regulations, right? Like if we rear end a car, if you rear end the car in front of you, even if they braked very rapidly, you're on the hook, right? If a car rear ends you as well, then you're like on the hook for the accident on the front, but not in the rear. That's at least in Ontario. I don't know globally that this is true, right? And how an autonomous vehicle drives will have to depend on the sort of both these like legal requirements of a vehicle, but also just like even social norms and things like that. And so it's something that isn't being considered enough right now, because the bulk of the development is happening in like California, Arizona, and, you know, not happening in many other places, right? Where regulations are different.
But I'm not particularly worried, Stefanie, about the sort of the traffic protocols or laws or regulations. We already sort of are primed to have consistent regulations from place to place, right? We don't have different stop signs in Ontario than they have in Alberta, because we need the humans to know what they mean no matter where they are. So the whole traffic safety field is kind of built on predictability and consistency. Those are design principles we use. So I think that programming it in a computer is actually maybe going to be easier than educating a human. Where I do worry about differences from jurisdiction to jurisdiction and sort of debates that are slowing us down is around the liability, and sort of different pieces of the whole system are actually regulated by different levels of government, and those different levels of government regulating things are going to need to be changed. So the actual public policy structure and changing that in terms of who regulates the vehicle versus the roads versus the liability in the event something goes wrong, those policy discussions can't keep up with the technology development that the engineers are testing in the labs.
Well, I'll pile on here because I think this is one of the more fundamental questions involving all this. If you take a step back, the idea of autonomous vehicles is that they should be safer, they should be better on a number of vectors. And in the safety aspect of it, it should be not less deaths, it should be 0 deaths, right? So I think the serious incidents should come down. fender benders will still happen, right? So there's just a bunch of these things that we need to get our heads around. At the end of the day, unlike in drug discovery, where in a trial they can get terminally ill patients to test solutions on, you can't do that in autonomous vehicles, right? You could maybe constrain the environment, take out some of the degrees of freedom and come up with elegant solutions that way, but you can't have solutions for terminally ill patients, right? So it's got to have 0 deaths in this whole concept. So that's become fundamentally across the entire industry, at least, a way to really understand how to play this out. So I will take I take a hit in the comments here. Somebody was correct in pointing out that Waymo is well surpassed a Tesla in autonomy. So thank you for doing that. But let's take an environment there where the vehicles are operating in autonomous mode. Like, what's the data telling us? What is it working at? What is it good at? And then let's flip the script a bit and let's take a look at, automated vehicles operating in constrained environments like underground tunnels, right? Like we could just kind of go through the whole gambit here of this. And we're going to see a lot of these solutions come out, or a lot of these test markets show us good information and data. And one, if not more than one, will succeed and become kind of a broad mainstream adoption of how this jurisdiction plays out.
Oh, well, thank you for that.
I'm also, I wish I had brought the numbers with me, but if you look at the number of miles of automated vehicle driving has gone on in the US before there was the unfortunate pedestrian death in Arizona. I mean, I don't mean to be cold-hearted about it, but in that same amount of time, many more pedestrians were killed by humans. And so sometimes I feel like the automated vehicles are maybe being held to an unfair standard, which Stephen kind of said a few minutes ago, but he stuck it in between other things. And I agree with Amar that we want 0 death has to be the standard, but we do need to keep it in context of the human drivers not performing anywhere near as well as we would like them to either.
Texting and driving is probably the number one problem that should be a benchmark.
Yeah.
Absolutely. Let's jump off that safety standpoint. I did see a comment come up specifically about Canadian winters, and I'm sure it's something, and I think it was specific to the technology of LiDAR and cameras. But like, I want to open that question up kind of a little bit more broadly and hear from each one of you about like the Canadian weather implication. Stephen, do you want to go first? Yeah, go ahead.
Sure. Yeah. This is another very good question, and it's something. Actually, at the University of Waterloo, there was a big project where some of my colleagues developed an autonomous vehicle called Autonomy, and it ended up in this new data set for driving adverse conditions, the Canadian Adverse Driving Conditions data set, I think, which is like, suppose like a nice data set that has snow, rain, I think fog as well, different things where it really challenges existing sensor technology. The other thing, and I think I saw this somewhere in the comments as well, or maybe it was even a question was partially answered, is this kind of these two fundamental ways that people are thinking of autonomous driving. One is like using these kind of HD maps, right? Where basically you have like centimeter or below accuracy maps of the entire route that you're driving. And if you have a foot of snow, this does not look the same anymore, right? And so these types of approaches typically don't translate so well to snowy environments. That being said, there are people working on all of this. Like, this is, I think, a really active area. And what, LiDAR doesn't work so well, but there are radar sensors that work very well. Some people are totally off radar for autonomous driving. And then some people think this is, the future, and they just haven't got the radar dialed in well enough. So I think they're great questions. I don't have the complete answer for it, but yeah, I'll let someone else continue.
Yeah, this is just we can get it to work here, we get it to work anywhere, right? So that's one of the big challenges. I would say infrastructure changes need to happen. There are things like lane keep assist, lane centering technologies those don't really work so well when half the lane is covered in snow, possibly has ice underneath it, right? So you got to follow the tracks. So these are situations where things will disengage or not be fully valuable. When I talk about infrastructure changes, there's been different materials used for roads that can have better temperature ranges for inclement weather. They can connect with the vehicle using some basic science. There's just a bunch of stuff going on here. The other area which is really great, there's in the industry, there's a couple of great companies, at least in simulation. So much like in other engineering challenges, simulations become a very important element here. But I come back to when half the lane's covered in snow and possibly has ice underneath, what are you going to do, right? And that's where a human brain knows what to do relatively where, probably half driven by fear, and that they're half driven by I've seen somebody else survive this, right? So it's not a simple thing. Back to my point on we can't test terminally ill patients with the drugs here, right? So it's got to have a zero death outcome.
I also think of the automated snow plowing equipment that's used in various places. And so it kind of anything's possible if that's the way you choose to invest your technology as a society.
Great, thank you all. Again, these questions are just coming in so quickly, we can't keep up, but we're going to do our best to try to get to each one of them. There is a question that came up specifically for Lisa, and it's about road pricing. And do you believe road pricing must be implemented to combat some of the increased driving effect?
Yeah, I mean, it's amazing that we don't price something as valuable in our society as transportation, and pricing schemes are being simulated by different research groups, and sort of one of the sort of most basic things to do, right, is to really highly price an empty mile, and that would motivate the need to always have at least one passenger, to eliminate deadheading, to pick up people on the reverse trip, and so that's most definitely being considered. It's interesting, though, that the policies that you would consider in the Greater Toronto Area and the city of San Francisco are very different from what you would need to use in rural areas or Northern Ontario, because of course in those cases you're going to have a lot of deadheading in order to provide the accessibility and mobility to maybe senior citizens that are living in smaller towns and villages. So I would say yes, pricing, but the pricing is going to need to be different in different places.
That's great, thank you. And you made a comment about how you're surprised it's not being adopted or in our society. Is that to say that other societies are doing it, or is that a global thing?
Well, I mean, we have some excellent congestion pricing experiments in various places. I guess maybe the most expensive one in London, England, correct? And we have no-go zones for cars in some cities. But for the most part, other than some dynamic tolling in some places, which has actually been shown to not accomplish all of the public policy goals we have, we haven't done a lot of pricing of transportation beyond pricing the fuel by volume when it's sold. So it's an interesting sort of fact that in the early 1900s, we made the decision that roads were going to be a public good. And so that's kind of a good example in the transportation system. It really is that we play for the long term. The decisions we make about everything in such an interconnected countrywide network, right, it has implications for a century. And so we want to be really, really careful with everything we do, where you put a road, where you build particular land use developments. Think about Mississauga around the international airport, for example. That land use and those highways and roads, they're there for a very, very, very long time. And so the system of not pricing has been with us for a century, and it's really hard to change it.
That's great. Thank you. All right, next question. Can you please talk about the tasks that are already working perfectly and the tasks that are needed to improve for the full autonomy level? And I'll open that up to whomever wants to answer it.
Did you want to go up, Amar? Yeah.
I should just call.
Still digesting
Sorry.
the question. Go ahead.
All right. In my opinion, like I think we alluded to it earlier, the things that are challenging are when the environment is more dynamic and less structured, right? So like highway driving, where you can stick in your lane. I think this is, there are studies or like large research projects going back to like the late 80s, early 90s in sort of autonomous platooning and things like that on highways. And I think this type of thing is possible. On the other extreme, like trying to navigate in downtown Toronto, like around the Eaton Center or something like that, where there's just people going everywhere. This is very challenging, right? And I think, just as you have more pedestrians, more like kind of unpredictable cyclists, everything like that, this is very challenging. I mean, the other thing that I think is challenging, we discussed, is weather conditions, right? Because basically it can be challenging for two reasons. One, it can be challenging in planning. Like I don't know where to go to be certain that I'm safe. And the other is it's challenging on the perception side. Like I can't tell if that's a pole or a bicycle, or I can't tell, right? And we've seen failures on both sides of these things, or there's glare on this window and it's shining back in my sensor and now I don't see what's going on, right? And so I think these kinds of corner cases are also very, very challenging.
Amar, did you want to add to that?
Can you repeat the question? Because I want to make sure I have the...
Maybe I didn't even answer it. I don't know.
I have to go back. Like there are so many questions. I'm trying to queue up the next one.
Well, I understood the question to be, what tasks are the cars good at now and ready to roll, and what tasks aren't they? So I thought Stephen answered it, and Amar, you would have good insights. But, one of the things that amazes me is that I do think, Stephen, that we're ready to roll on the freeways, and yet we have these cities and congestion in cities as sort of our motivation, and the cities are the change agents trying to push these developments, and there's sort of a mismatch there. And it kind of surprises me that we're not geofencing the freeways for level 3 or even level 2 automation, but level 3 automation. We're going for the cities first when the technology is ready for the freeways.
Yeah.
Yeah, the irony is stark. Sorry, I didn't mean to jump in there. But
No.
I think for various industries, highways are a critical part of their infrastructure. Let's call it trucking, delivery. It's super critical. Driver fatigue is the #1 cause of truck incidents. The freeways have proper infrastructure. They have generally well-maintained services. They have resources facilities. They have less variables. There's usually not pedestrians. The change in speed, or the variance of speed between vehicles, is usually, as a percentage, quite low. And there's not a start-stop issue typically. So it makes it a less complicated problem for 80% of the time. It's that 20% that we got to get right. But I'm in agreement, and some of the other questions talk about infrastructure. If you had a fully autonomous vehicle, could you be on the faster lane, the faster freeway? These are all things that, when you kind of look at it as a global system here, we got to put it in context, because I think those would be great ideas, right? You're willing to invest in the safety and be there. We'll let you go 100 miles an hour, right? Go ahead. So I think there's really good context in this question.
I couldn't agree more. There's such great conversation, and there's so many issues and but advancements. It's a great conversation. I want to change gears a little bit, and Amar, I'm going to start with you on this one. And I'm really excited because I think our audience definitely wants to dive into it. But we are seeing an increasing prevalence of cybersecurity issues, including ransomware. How can information security be tested to an appropriate level to ensure bad actors do not find a way to compromise our vehicles, and the wider implications of cybersecurity?
It's timely. There was some article that came out today. One of the crypto tokens was hacked, and a bunch of questions. Was it? Did it go through security audit? All this kind of stuff, right? And communication security started as a firewall box in the network many decades ago, and has now evolved into being a fundamental element of every piece of information shared or communicated. So it's inherent in the DNA of the fabric that we stitch things with. So it's critical. It's important. Audit of things is critical. Not having one person or one group holding keys is another. I think there are some schools of thought, and I'm not deep in the research on some of this cybersecurity stuff, but as a user and an implementer of a lot of it, you're only as good as the next trick, right? In this cybersecurity game, and platooning vehicles with a malicious intent on the freeway would be bad. Platooning vehicles to reprogram them to do bad things would be bad. You see some of this in some of the Hollywood movies. It was one of the Fast and Furious movies, right? You're just like, oh, that would be really bad, right? And what's to stop it from happening? It's security of information or security of communication as well. So it's high on the list. It's one of the reasons that things are in the development cycle. It's taking longer to get this part done because it's inherently harder, right? It's inherently changing by the minute, by the hour. So if anybody has in the audience a good place for us to get resources and to get better at it, drop it in the comments. Let's go.
There's a fine line though, right, Amar, between security and privacy. And I actually think that we can maybe address security, we do on airplanes, ahead of privacy. The bottom line is, in a connected autonomous vehicle, you're not going to go, it's not like turning your cell phone off and nobody's going to know you were there. I mean, you're being tracked.
This is a great topic. Yes, you're going to be part of a system infrastructure of privacy, right? They're going to know who, where, when, likely have video capture of it. Today, the human behavior is, that's okay as long as I'm controlling it through my cell phone. Like we go through a lot of personal information challenges every hour at the office, right? And then we come back to, do you do it on your phone today, right? And it's not a solution. It's just a gut check. What are we as a society comfortable doing? In fact, some of the driver assistant apps, like take insurance for example, they're asking you to track you through your phone, and they'll give you a discount, right? And it's like, great, I want the discount. I'm willing to give you access to my speed, my location, my time. And then the situations, in our platform, we know all vehicles at all times. I shouldn't know which one has the entire executive team of the company or the lead engineer on certain project, right? Like I shouldn't be able to tell you that information, right? So it's an incredibly important field. I could go deeper on it, but it's probably going to defeat the purpose of having privacy and security for me to talk about it here. But happy to dig deeper with some good questions here.
Riding on the coattails of communication, Amar, there's a question that came up specifically for you, and it's for AVs communicating with other AVs. Has there been development of a common communication platform?
Yeah, there's been some attempts, different groups. Generically, there's something that's come about called V2X. And that the concept there is it's vehicle to anything communication. The context was it would be a vehicle to some kind of network before, and now we want to arm the vehicles to talk to each other. As an example, simple safety. Hey, I think you're going too fast, or you're too close, or I am an emergency response vehicle. Please pull over. I need to get through. There's just a number of simple use cases you could articulate here. and some of them should be vehicle to vehicle. Some of them should be, network to vehicle. And we're early in it, right? The use cases aren't solved. And back to some of the earlier issues around, cities versus freeways. On a freeway, we could be able to articulate vehicle to vehicle stuff quickly, like, hey, slow down. I see you're coming really fast in my rear. There's a traffic jam ahead, or I'm an ambulance. Please pull over. Like, these are basic use cases we could do today, but we're likely wrapped up in some red tape.
Oh, great, thank you. Next question. There are select use cases full for level 5 and level 4 already in place for mining, for example, Caterpillar's MineStar system. Do you see that these types of use cases will roll out more quickly? If so, in which industries do you see the highest economic return on CAAB investments? Who would like to go first? Go ahead, Stephen.
Sure, I can. I definitely agree. I mean, I don't know if it's the true Ryan Greppi, but I saw in the comments that someone of that name posted a question. Who's one of the founders of ClearPath and Auto Motors, and so probably has a lot to say on this kind of thing. But yeah, in places where vehicles move more slowly, and maybe in slightly less dynamic environments, people that are walking around are either trained to be around autonomous vehicles, or at least know some like basic protocols on how they should interact. There's lots of examples of like level 4 or level 5 autonomy, like in warehouses, automated material handling, mining, agriculture. I think there's plenty of applications, and there's lots of companies, lots of activity in this area in general. And I think, yeah, we're really in this discussion, I think we've been focusing on road vehicles, which would be a huge market, but these other ones are by no means small markets either, right? They're each gigantic potential. So, and it is him. Yeah, he said, sorry. I saw the quick response. Yeah.
Awesome.
Yeah.
Thank you, Stephen. I've got another great question here. And this one I think is a great one for you, Lisa. Since the basis for autonomous vehicles are mainly electric, how do you see taxation changing in the shift to electric vehicles, given that gasoline is heavily taxed and theoretically those revenues are used to build and maintain road networks?
Yeah, so that's a huge challenge, right? All sorts of jurisdictions can't figure out how to move from gasoline revenue to electric revenue, even though we all know we probably need to electrify the passenger transportation system. And on top of that, we know that time of day pricing of the electricity we put in the cars needs to be an important part of making sure we use solar energy when the sun is shining to power those vehicles. So I guess I can't really offer more than the questioner is sort of saying, in that it's a huge challenge. But I think that the motivation to make that leap now to sort of maybe like a utility pricing scheme for transportation, I mean, with every passing day, the motivation gets stronger and stronger. It's not just about needing the revenues on the transportation side. It's about needing to manage our electric grid, sustainably in terms of through a 24-hour period in the seasons of the year. So we're going to have to see that change.
Thank you. And this is an interesting one. Do you expect roads in the future will not allow cars which are not AV? And this one I think is like a spicier topic. So happy to have a response from all of you.
No, I can go. Oh, sorry.
I was going to say they forced us all the digital TVs, didn't they?
Yeah. I think for the most part, no. But I'm kind of guessing. I probably know the same amount as, I can predict that as well as the person asking the question in some sense. But just the way I see things happening is it's kind of this like general creep. It's not like all of a sudden, it's like July of 2026, autonomous vehicles are released and we now go out and buy them. It's like our cars just become more and more capable. Tesla is very good at just pushing the envelope in this, right? They're kind of all sneaking it under this level 2 type thing, but what their cars are capable of kind of goes beyond that, right? And we'll just continue to see this creep. But at the same time, there'll be many people that just own, gasoline vehicles without any sensors on them. And so maybe, at some point they'll build a new road that's an AV specific road, that kind of thing. But I don't think our existing, like the 401, will change anytime soon. That's my, semi-uneducated guess.
Yeah, I think that's a great, I love the insights there. A few things, right? It'll be an adoption curve, some kind of hype curve that we go through here. Experience that we've seen before, high occupancy vehicle lanes, right? That was to see if you could carpool, get around traffic. We've seen mixed results. I'll paint a bit of a scenario. If you could take turnpikes, Route 66, the Trans-Canada Highway, these types of systems, or beltways of major cities, and say, look, if you have this automated system and pick your flavor of the day or alphabet soup of it, you get access to this, you will see a rapid adoption of these technologies. You just will, right? That's just human nature. If I can do it, I will. If it saves me time, I will. If I have to pay for it, I will, right? We see that across a lot of technology now, and I don't see that being different in this context.
But I do think it goes back to the planning horizon, because it takes, in excess of 15 years to turn a passenger vehicle fleet over in our society. And way back in the comments here, I don't know, about 2/3 of the way through, one of our listeners sort of pointed out, there's going to be this huge phase where the humans are on the system with these automated vehicles. And I do think I can be critical of my own field in transportation systems modeling, that we've done a lot of really exciting modeling of when every car is an AV. But the reality is that that's not going to happen anytime soon, that the more critical thing that in the behavior field we should be modeling is when we have these mixtures of vehicles and what's going to be necessary for the humans and the AVs to interact well together. And so I do see that we're going to very slowly move to a future where some vehicles don't have the technology to be allowed on some parts of our infrastructure, and that's okay. But I'm in this realm of sort of saying, gosh, I think they might have made a decision wrong in 1930 and we're still dealing with it. Like that's the temporal speed, that's the speed of development in the transportation sector. So we really need to think about these things right now, because the decisions we make are going to affect what's possible 20, 30, and 40 years out. So it matters to think about the transition and to prepare for a time when only certain vehicles will be in certain places. That's going to happen.
Great, thank you, Lisa. I'm gonna kind of get back on board with our schedule talk to make sure that we've addressed the questions that we promised in the original email that went out. So future outlook. Our last section is about the realities. Waiting for AVs can feel a bit like forever construction that plagues Canadian summer short driving season. What are we waiting for? Why can't I already take a meeting or enjoy a nap on my way to Pearson? Amar, first question to you. What do you see in the future for data security in AVs?
We touched upon this earlier in one of the questions. If it's a repeat question, I'll stick to my previous answer. If it's a gut check on my response, let me see if I can dig a bit deeper. We've seen so many breaches of information on the internet in the last number of years. Credit information, stolen profiles, the dark web has a lot of information on people. The social networks have a lot of information on us, right? Like these are meaningful pieces of information that identify us. So if I go to the privacy side, we have to really understand what is required for these systems to work. I'll give you an example. If you ever use a rental car and you connected your phone via Bluetooth, you probably accidentally downloaded your entire address book, right? So like these are just things that happen today on a privacy side where you're like, this we can probably solve some of them, but we have to really, as a society, understand, what do I need? Do I need your name? Do I need to know where you're going? Do I need to know the time of day? If I give access to that information to somebody, do they know where you live? Do they know where you work? Can they identify you? These are just really critical pieces. And that is part of the outcome of having the security piece tightly wound and integral into every transaction and communication that's going out there. So a lot here, and a lot of situations where the more information you give, the better the output could be. And on the flip side, it's a double-edged sword. The more disastrous the outcome could be, right? So, I'll pause there.
Thank you. That was great. Lisa, will autonomous vehicles improve the transportation sector's environmental record, including its contribution to Canada's greenhouse gas emissions?
We cannot afford to wait for autonomous vehicles to address the transportation sector's contributions to climate change. I'll leave it at that. We need to be taking action now on that matter.
Awesome. And there's a follow-up to that question. And what infrastructure or policy are we waiting on to make AVs a reality?
I think, and I can see the phrase she didn't read, to make it a reality in our cities. And I think the policy or infrastructure we're waiting on is to focus on the long distance travel on the freeways instead of the cities. I think it's to convince cities that connecting themselves to other cities is the place to apply this technology, and to sort of leave ourselves some time to deal with how we avoid running over the children and the dogs within the cities. That pedestrian problem is just loaded, and we have a way to eliminate it. Let's just focus on the highways.
That's great. And Stephen, how do you think drivers will adopt AVs?
I think I kind of answered this in the last question, where I do kind of think it'll be this gradual creep, like our cars will become more featureful and we'll have more options. I mean, two other things that just very briefly, like we'd mentioned trucking, right, is another place where I think at least there's a lot of bets on this, right? Big companies, some out of Waterloo, like there's Embark Trucks, which is a unicorn many times over, right? And then the other one are things like, delivery vehicles. So within cities, slightly slower driven, or like designed for a particular use, where I think we'll start to see, one of the big companies there is called Neuro. And so there's exciting things in these types of places where maybe we'll start seeing vehicles like that in urban environments, right? More on freeways.
Thank you, Stephen. I'm going to do a quick summary to just talk about everything that we've gone over, although I don't think I can capture it. There's just been so much here and so much involvement from the audience. So we're going to do that, and then we are going to go to a full Q&A where nothing will be scripted, and we'll try to address the many questions that have come in. So, from autonomous vehicles to like comparatively thinking of them, are they, autonomous versus automated? And categorizing them so we can better understand and then advance how we talk about each one of those applications or the realities of them. From the wicked problems to the exacerbation that AVs are going to cause more driving, not less, which is a little bit counterintuitive, and we need to be thinking about these things. And back to that thinking, the things, technology advances more quickly than some of the thoughts that we have around should we build this. And does it make sense to do this instead of we're already there? We've built it. Now take steps back and think about how we implement it. To, sharing technologies, like who's sharing and amongst who, like, are they people living in the same environment, same household, or are they geographically sharing between cities? And, now that we're connecting cities one together, what does that mean? And then, the thinking about the drivers and autonomous vehicles, maybe for those who are a little bit more hesitant to their adoption, like thinking of humans as the current computer. So AVs aren't a simple, a new technology. They're just changing the way we do something currently. So having computers take over for what humans naturally do, and then how to do that, with that zero tolerance. Even though human drivers are allowed a lot more tolerance than we do AVs, how do we make sure, pedestrians are safe, and at the same time, make sure that we improve upon the death rate that is caused by human drivers and cell phones and the wider implications. And in terms of security, auditing is critical. And, there's information and communication, and we need to make sure that, we avoid the predictions of Hollywood and stay one step ahead of what could happen and the most scary implications of security losses for autonomous vehicles. So with that, I want to say thank you so much to my panelists. You have had such a rich conversation and just the wealth of experience and depth you brought to this. And thank you to the audience. Please bring those questions in because we're going to switch this conversation. I know we've gone a little bit over time, but we have extra time built in for some questions. So let me get my question and chat up and if anyway.
There's one question.
Yeah, please.
Questions in here around AV, internal combustion versus electric. This is a simple. Any vehicle can become an AV vehicle. Let me describe to you one of the practical challenges in a combustion engine vehicle. Vehicles have a ton of software on them. Most vehicles, when you drive them off the proverbial lot, are in their best days of their life. They don't get better over time generally. With the use of software now, we can make vehicles better, but that requires updating your software. And much like your phone and your computer has an auto update or capability, we need to put that in a car. Imagine this: you have a vehicle in a garage. It's a combustion engine, and it needs to power itself on to update the software for 2 hours. It's gonna be a bit of a problem. So there are some limitations and capacity problems with how updates can work, because some updates can't be done while the vehicle's in motion. So then you have to keep it running, and to have it running for hours in your garage is probably not a good thing. I don't recommend it. So we're just working through all these practical limitations of things, but the answer is yes, anything can be an autonomous vehicle.
It's interesting, Amar. I caught the AV versus EV thing in many of the questions too, and was going to say they're very distinct things, and we want to use them strategically together, both for the reasons Amar's outlining as well as for emissions and how we encourage sharing. And but AVs and EVs are not the same thing.
That's great. And to my panelists, if there's a specific question that you want to answer, please jump in here. There's been a number of them, and I don't want to, if there's one that you're particularly keen to answer, please jump in.
I want to thank the audience for raising a couple of times the issue of jobs, with Stephen's comments about trucking and the movement to automated trucking. We do have to think about how will those drivers be reemployed, but also the retraining of mechanics and people who work on maintenance of vehicles. There's a whole job sector, workforce development thing to discuss with respect to these changes in the transportation sector.
Lisa, as my current or my past life as a mechanic, I appreciate that you thought that up. It has some big implications for mechanics, and I saw programming when I did my apprenticeship of vehicles regularly, and it's increased tenfold since then. It's significant.
Yeah.
Were there other comments to add, Stephen or Amar?
No, nothing specific, I think.
Okay. Then I'm going to, we talked about this, I mean the panelists and I, about this kind of fun question. I think we should end on, unless anything pops up in the chat, and please feel free to interrupt. But, when will we see EVs dominate our roads? And that's a question for each one of you. So Amar, could you please start?
I will predict I will have a flying vehicle before the 80% penetration rate of autonomous vehicles.
2060.
It's a total guess. Yeah, I don't feel I have any particular insight into the dominant part. So I'll be more optimistic and say 2040, but I could be off by 30 years.
I absolutely love the no hesitation from each one of you. That was awesome, because I can imagine that the Q&A must be going crazy. So thank you everyone. Thank you again to my esteemed panelists. This has been just such a fun conversation. And thank you so much to the audience for being just so incredibly engaged. We were just in awe by all of your questions. This video is being recorded, so you can watch it again. And feel free to connect with me, definitely, if you have questions, and if there's a way I can disseminate and get you some more answers to that. But this has been wonderful, and we really appreciate it. Any other thoughts, panelists?
Thank you,
No.
Stefanie.
Yeah, thanks everyone. It was fun. Thanks for all the great questions.
Great. Thank you, everyone, and have a wonderful day.
Bye-bye.
Bye.